Hello everyone and welcome back to another video. Today I on register number URK20CS3026. I'm going to explain to you experiment number 7 of Designs and Analysis of Algorithms lab. So today we will be doing minimum spanning tree using Prim's algorithm, and Prim's algorithm, it is implemented using greedy method. So let me tell you in brief what Prim's algorithm is about. So in Prim's algorithm we are given a graph, and in this graph we take the minimum most each edge between the two nodes. So we start with the minimum edge, whatever is having the minimum distance, and from there on to which two nodes it's connected. We check in those two nodes to whichever other edges it is connected, which is the minimum edge, and among those edges, whichever is minimum, we connect that to whichever node it is connected, and from that node and then from the other nodes which we have connected to our minimum spanning tree, we check which is the minimum node, and we connect the node based on the minimum node. And because we are considering the minimum and we are in each step of the process, we are calling this as greedy method, and we continue the same process considering the minimums of every node that is connected to our graph. And once we have connected a vertex, we don't connect it again, so that is why we have flag for that. And so we set it as traversed, and after that we just continue so on, adding the nodes and edges till the time we get a minimum spanning tree of all the nodes of the graph and n-1 edges. So this is the code that is used for a minimum spanning tree. This is the definition, and we also import sys library, and from that sys.maxsize function is called to get infinity. After that the output is given, but first let's start with the input. So here we have a graph variable which is going to be a 2D array, in which we will be taking the input of our adjacency matrix of the graph. The length of graph, we assign it as n. So length of graph will basically contain how many nodes are there. For each node we will have a list of outgoing edges, that will be a list, and such how many lists we have is what will be given out by len of graph. And after we will be just giving node numbers. So nodes is equal to string of I, will be making them in the range of 1 to n plus 1. So we will be assigning all the nodes numbers, and after that we will be calling the source as the node of 0, so the 0th node. And after that we will be calling MST of graph comma s, that is we will be calling the MST function and passing the parameters graph and source node to start. So in the MST function over here we have got the parameters as the graph and the source node, and after that in MST function we will be creating a list called as distance, in which we will have items set to infinity for the n nodes to calculate the distances. Then we will be having the same way for a traversed, which is a boolean list, all set to false initially for the n vertices of the graph. Then we initially set distance of the source index, the index as source. In this case it is 0, so directly distance of source index will be set to 0. Then we have parent, which will be set to -1 initially, star n, for n number of the nodes. And as we get the nodes one by one, we are adding it to the MST. We will be like changing infinity to whatever the distance of the edges is, and accordingly we will be adding the parents of each of the nodes to the parent, and we will be making this true for each of the nodes that we have traversed. So that is what we do below. Here in the for loop we will be setting initially a minimum is equal to infinity, and after that we will also have a current which is set to -1, just like how we had done previously. But from this, when we run this second for loop, that is the checking for the greedy method, in this, if it is not traversed, if the node is not traversed in n, and then if the distance is lesser than the minimum, that is initially it's infinity, but if it is lesser than like every iteration, the minimum will keep getting lesser and lesser. So if the distance is lesser than that, in that case we will be setting the current as I and the minimum as distance of I. So this we will be doing it for everyone. This is just like finding what is the minimum most edge that we have, and minimum is equal to distance of I. After that we will be setting traverse of current, that is the current edge, we will be traversing it as true, and then we will be running a for loop of I to n, in which we will be attaching this node. So if not traversed of I and graph of current of I is not equal to 0, that is if it is not traversed, and if yeah, from the smallest node to I, whatever the node is, that is if it is not equal to 0, that means if there is any other node connected, that will not be equal to 0. In that case, if the current distance is lesser than the distance of I, that is if there is already this node has been connected somewhere else, in that case, if this has a lesser distance here, in that case we'll be appending it to the graph using this. So distance of I is equal to distance graph of current to I, and then parent of I will be node dot current, that is the current node will be assigned to the parent I, and after that for the output we'll initialize cost variable to be 0, and after that we print for edges in the MST, and then we run this for loop. We give the user the output as we'll be giving out the minimum cost of each edge to be traversed and the order in which it is traversed. So it will be all done according to this parent list that we have. So parent index of 0 will contain the parent of the 0th node, and from that parent of the 0th node to come to the 0th node, that is I, nodes dot index of parent will give the index of the parent wherever it is in nodes. So that index, graph of that index to I, it will give the distance that will be added to cost, and we will be printing that from the parent to the node. It will cost us this distance, and then after that we'll be printing so on for all the vertices, like from each parent that is there for each of the nodes that we have found the minimum. We'll be printing all those vertices, arranging in parent. Each of the parents of each node, they are arranged in the minimum order as per greedy method, and so we print all of them, and finally we print out the minimum cost as cost. So let's run this program. This is for the adjacency matrix of the graph. So if we enter adjacency matrix that I have already taken before, so this is the adjacency matrix that I had entered, and so now it calculates the minimum spanning tree. From 1 to 2 it is 4, and then from 2 to 3 a minimum of 8, 3 to 4 a minimum of 7, and then it adds 3 to 6 a minimum of 4, and then 6 to 7 it is a minimum of 2, and 7 to 8 it has a minimum of 1, and 3 to 9 it will have a minimum of 2. So like that it goes through all of this, and finally it gives out the minimum cost to be 37. The result is that the minimum spanning tree has been found using Prim's greedy algorithm. So thank you guys for watching. Hope you liked the video. If you did, do give it a like, do subscribe to my channel for more such interesting videos, and see you guys in the next